Conditionals can be translated. Let's take the statement, everyone in this room will pass. How do we translate this to if P then Q form? Well, this says, and you would probably agree that if you're in this room, then you'll pass, because it says everyone in this room will pass. So we can let P stand for in room, Q for pass, and we can say that if P then Q translates this statement. If P then Q is another way to write it. If you're in the room, then you'll pass. Okay, second statement, nobody in this room is going to get $1 million today. What's that say? Well, let P stand for you're in this room, and Q stand for going to get $1 million. Now to say nobody in this room is going to get $1 million says what? It says if you're in the room, you ain't going to get that $1 million, right? So it's equivalent to say if you're in the room, you won't get $1 mega here. So again, that's a statement. Now that would be written if P then not Q in this case. That's still in what we call if P then Q form, but we're going to use the not here because this is a negation of getting $1 million. You won't get $1 million. We usually don't make our propositions negative. We usually write our propositions in positive form. Okay, statement. A triangle is a polygon with 3 sides. How do we make that an if P then Q? Well, actually P is going to be a compound statement, and we're going to say P stands for a triangle and a polygon, which we might symbolize as T and, we can't use P for polygon, so we'll use G for gon. Now, it's a triangle I've written this wrong. I'm going to have to go back and rethink. It's not a triangle and a polygon. We're going to say 3 sides and a polygon, and we're going to call that Q. Okay, so 3 sides will still let be T, so that's T, and a polygon we're still going to let be G. A triangle, that's going to be P. We're going to say if it's a triangle, then it's a polygon with 3 sides. So we're going to say, okay, P stands for it's a triangle. So if it's a triangle, it's 3-sided and a polygon. Now actually, when we make a statement like this, a lot of times it means an equivalence. Okay, so sometimes a mathematical statement will be an equivalence, but then we would say it's a triangle if and only if it's a polygon with 3 sides. So this is just saying if it's a triangle, if it's this, then it's this. Okay, what about this one? 2 will be less than 3 when cows fly. Well, we can let P stand for 3 less than 2. I think I said that backwards. 3 less than 2. And Q stands for cows fly. Then we write this statement, if P then Q. And finally, if you win, then she loses. So let P stand for you win. We have a couple of choices here. We could let Q stand for she loses. Then if we have an if P, then Q. Or we could have if P, then not Q, where Q stands for she wins. There are various ways in a lot of cases to translate. The thing that's wrong with saying she loses is that might be taken as a negative. She doesn't win. But losing doesn't necessarily have to be taken logically. Doesn't necessarily have to be translated as not winning. That's a point I'm just going to leave for right now. In any case, here you see various ways of translating conditionals.